Today's word is incidental, accompanying but not a major part of something.
Oil prevents rust, corrosion, and displaces moisture and keeps parts clean. Oil lubricates, reduces friction, and removes heat. Oil prevents wear, maintains machine surfaces, and provides smooth operation. But with all the benefits of oil, it can't prevent all the world problems. This video is going to take a look at vacuum pump oil, how it's made, what's it for, what it is, and what it is not, and whether all vacuum oil is the same or is it different. There are hundreds of different types of vacuum pump oils. This particular oil, which is clear, is provided and distributed by Harvest Right and comes with each sale of a freeze dryer. This oil has just a hint of a yellow tint and is extremely popular among HVAC users, and this is black gold. And then this is the former darling of the freeze drying community. In the early years of the freeze drying craze, Dairyland was all the rage, but this oil has recently fallen into disrepute. But we're going to take a look at these oils and what's in them, what they're used for, and all this information can be found in SDS, formerly MSDS. So we're going to take a look at the SDS sheets provided by the manufacturers to find out if all vacuum pump oils are the same, or if they have unique specifications and qualities, so we can determine which oil is best for you.
We're going to take a look at the three most popular oils used for freeze drying, and that is black gold, Robinair, and Dairyland. Information on these three vacuum oils was obtained from the SDS sheets, formerly MSDS sheets. The manufacturer for black gold is Phillips 66. The manufacturer for Robinair is Bosch, and for Dairyland it is Stearns. The ISO grade, which is the same as the weight of the oil, is 46 for black gold, 32 for Robinair, and 68 for Dairyland. To kind of put that in more perspective, this would be equivalent to 10 weight oils and a 20 weight oil that is often used in automobiles. The percentage of base oils is 95% for black gold, 100% for Robinair, and greater than 99% for Dairyland. It should be noted that both black gold and Robinair basically has the exact same base oil, where Dairyland has a base oil being paraffinic mineral oil. The additives for the three oils are as follows. Black gold uses UV stabilizers and antioxidants. Dairyland has a host of different additives, including wear, anti-foam, oxidation inhibitors, and corrosion protection, and they also add a dye into their oil. Robinair is the only oil that contains no additives. The most important review of these three oils is that all three oils are not identified or approved to be food-grade oils. What is food-grade oil? The National Sanitation Foundation, who was founded in 1944, also known as NSF, created standards for food safety and for manufacturing. NSF is accredited by NANSI, which is the American National Standards Institute, which is a gold standard for safety and production. OSHA and the FDA both recognize NSF standards for food-grade oil. The guidelines for lubricants being used in and around food preparation found in the Code of Federal Regulations, or CFR. In Title 21, it explains what a food lubricant is. Lubricants with incidental food contact may be used safely on machinery used for producing, manufacturing, packaging, processing, preparing, treating, packaging, transporting, or holding food subject to the provisions of this section. This includes freeze dryers. The key word here is incidental. There are three food grade designation, H1, H2, and H3. In the freeze drying community, or in the freeze drying businesses, or in freeze drying production, H1 is the one we want to take a look at. H1 indicates the specific lubricant acceptable for incidental food contact and can be used in the processing areas. Once again, the key word is incidental. H2 and H3 are also lubricants that can be used for food preparation, but do not come in contact with the food. Vacuum pump oils which have been approved to be used in and around food production will be clearly marked on SDS sheets, the packaging, and other literature from the manufacturer. If it's not marked, it's probably not a food grade oil. In normal freeze dryer operation, the flow of air is one way. It goes from the freeze dryer to the vacuum pump. A check valve located at the vacuum pump prevents the reverse flow of air from the pump back to the freeze dryer. The check valve prevents any oil from going from the vacuum pump back into the freeze dryer. If the check valve on the vacuum pump fails, this will allow oil to make its way from the vacuum pump back into the vacuum chamber, being drawn there by the vacuum. This will then allow the oil or the oil mist to contaminate any food that's in the vacuum chamber. This is incidental contact. Because of the check valve and the direction of airflow from the chamber to the pump, under normal circumstances, oil should never contact the food. What is food grade vacuum pump oil? In order for an oil to be considered food grade, it needs to be made from this FDA list of non-toxic approved ingredients. Who needs to use food grade oils? Well, it comes down to what your purpose of having a freeze dryer is. If you're just freeze drying food for you and your family and maybe your close friends and neighbors, well then you're okay, and you can revert back to the song, "Don't worry, be happy." However, if you are a commercial seller, you might want to think twice about the foods that you sell. You might want to contact your health department to find out if there's any regulations or requirements regarding food grade oils in possible contact with food. And lastly, consider any liabilities. It might just be a safe thing to do if this is your business or if you're a commercial seller. One thing that freeze dryers have in common is that we all abuse vacuum pumps intentionally. There's not a single vacuum pump manufacturer that recommends introducing water or moisture into their vacuum pumps. Moisture in a vacuum pump can be detrimental to the life of a vacuum pump, and so it is extremely important to keep or prevent moisture from entering the vacuum pumps. But in the freeze drying process, this is almost impossible to do. Water is one of the most destructive elements in freeze drying. Whether it's in our freeze dryer pumps, or in our oil, water needs to be removed, and no matter what we do, some water will always remain. Regardless of the type of construction of the pump, or gas ballast, or even the type of oil we use, water will always get into the oil, and water is the one thing that we need to get rid of. It was this reason that Dairyland is no longer recommended by Harvest Right. It has been claimed that Dairyland oil retains water and gives off a foul smell that is not desirable. This is a basic review of the ASTM D1401 test, and this test basically measures what happens or what should happen when you mix oil and water together and how quick should they separate. So we start here with 40 milliliters of water and with 40 milliliters of oil, and the water is distilled water. From the start, we go into the next stage is to mix the the liquid into an emulsion, which usually comes up to be a cloudy color. And then the stopwatch begins, and we go for 1 to 10 minutes at 1 minute intervals, and then every 5 minutes up to an hour. In my case, I went from a half hour directly to 1 hour. And during that time, this mixture should start to separate. At the result of 1 hour, this is basically an example of what we should have. We should have a clear border of oil at the top with a clear separation of water on the bottom, and this little border between the two, which is the emulsion, or also called the cuff, is allowed, but no more than 3 milliliters. Sometimes it will be 0. This is what we're looking for. If the result after 1 hour is this sample right here, then the oil would be approved. If you take a look over at this one, the cuff is much larger than 3 milliliters, and this would be a failed test. During this stage, the water temperature is held at 130 degrees. During the mixing stage, the mixer is at 1500 RPM for 5 minutes. Our first test sample is going to be the Harvest Right Robinair oil, which is extremely clear, and of course our water. We're going to go ahead and put the oil in the beaker to warm it up. Followed by the water. And we'll give it time to warm up and for the oil and water to separate before mixing. So the Robinair Harvest Right oil has separated, and we have the mixer inside the flask, and we're going to go ahead and turn that on. It has been a full hour on the Robinair. Now, the Robinair is straight petroleum mineral oil, basically. It does not have any additives, which could be a drawback and problematic with this particular test. You can see up here at the top, the oil has separated, but then down here at the bottom you can see what's called the cuff. This is kind of the homogenized oil and water blend. Down at the very bottom, there should be a band of where you can clearly see the water line. But the water line really isn't there. What little water you can see is blended into the cuff. And the cuff right here is roughly about 37 milliliters, and according to the regulations, the maximum amount of cuff you can have is 3 millimeters. So I'm going to leave the cylinder in the 130 degree water. It's been an hour, and I'm going to give it a few more hours. I'm not doing anything, and we're going to see if we can develop any kind of a water line down here, and if this 37 milliliter cuff will eventually disappear. It's been about 6 hours, and you can finally see a separation here where the water is and the oil is, and up here you can see the small amount of cuff. And that is probably within the 3 milliliter range. But the problem with this is now 6 hours, and the test is only permitted for no more than 1 hour. So although the Robinair oil eventually separated, it took a long time. If you take a look down here in the separation where the water is still just a little bit of milky, has a little bit of milkiness in it, which is a sign that there is some oil still suspended in the water. And so that's an interesting thing, and I'll let you make the conclusions yourself on this Robinair oil. Our next test oil will be Dairyland, and this is an oil that has the blue dye. The Dairyland is in the graduated beaker, and we're going to warm up the oil to 130 degrees. And to the warm oil, we're going to add 40 milliliters of distilled water. And we're going to let that sit and warm up to 130 degrees before mixing. The 40 milligrams of oil, the 40 milligrams of water have been heated to 130 degrees and have separated. And this is what we hope to have at the end of the mixing cycle. So we're going to go ahead and start up the mixer. The oil has been mixed, and now we'll start with our timer on how long it takes to separate. We're at 1 hour, and so we're going to go ahead and take this out of the bath. The next sample is black gold, and this, if you compare black gold to the clear water, black gold just has the slightest tint of yellow. So we're going to go ahead and add the black gold to our beaker. And we're going to go ahead and warm up that oil. And we're going to go ahead and add the water. And let that warm up to 130 degrees. We're at temperature and we have full separation of the oil, so we're going to go ahead and start mixing. Robinair was the first test that we performed, and this was a little bit disappointing. Robinair is a pretty good quality brand vacuum oil, but in the test it failed pretty bad. There was no real separation. The cuff amount was way over 3 milliliters as allowed, and even after 4 hours, the water really never separated, and the water pretty much stayed in emulsion for the rest of the day. This really was not surprising, because if you take a look at the SDS sheet for Robinair, the base oil is pretty much 100% mineral oil, and Robinair does not add any additional additives or chemicals to their oil that would help the water and oil separate better. Second test was Dairyland, and this did a little bit better than Robinair, only to the point that there was a clear separation of water at the end of the test. It was only about maybe 5 milliliters, but there was a separation there, but the cuff amount was excessive, and because of the cuff size, the Dairyland oil also failed. The black gold was almost an absolute perfect test. After 1 hour, there was a clear separation of water from oil, and the water was clear. It wasn't cloudy. It didn't show any portion of oil being emulsified within it. The cuff was only about 2 milliliters, so it was actually less than the recommended or passable amount. And of course, the oil was up here at the top. Now, the oil still had some water emulsified within it, because it did not come back to that kind of the off yellow clear color that the original oil had. But even though some oil was still emulsified here, this would have passed the ASTM test. These are the SDS, formerly MSDS, for the three vacuum oils that we worked on. So we have Robinair, we have Dairyland, and we have Black Gold. So if you take a look at Robinair, Robinair is 100% basic petroleum. It doesn't have any additives. And if you want a better explanation of what this is, well, here it is. And you can read through that. It doesn't make a lot of sense to me, but this is what Robinair is. Now, at Dairyland, Dairyland is almost 100% paraffinic mineral oil. It's just short of being 100%. That's probably due to some additives and also the dye that they put into their oil that makes it blue. Black Gold has a whole lot of additives, and these additives here are what's called R and O additives. It helps fight rust and oxidation, and also has additives that help the oil separate. And this is why Black Gold did so well in our ASTM test. The Black Gold and the Robinair in their base oils have almost similar base oils, although Black Gold has additional additives.